So we're asked to find the partial fraction decomposition of this. So as you can see, we have combination of a linear and a quadratic function at the denominator, because that's the major determinant on how to decompose it. We look at the denominator, we have two factors. We have a linear factor that is repeated, that's all squared, meaning that we are going to decompose this as a over x minus 1, that's the first one, b over x minus 1 squared. Because of these two, if it's 3, we still go one more step. So looking at this is a quadratic factor, so the numerator will be a linear factor, so that's it. So if it's quadratic, linear, if it's linear, you know it's a constant, 0 degree polynomial, so that's how we split. So the next step is to multiply by their LCM, and the LCM is this. So if I multiply the left hand side by the LCM, we are left with 10x squared plus 2x. While if you multiply this by the LCM, which is this, we are left with one of the factor, that's a times one of these times x squared plus 2. Why this? If I multiply this by this, so we are left with b times x squared plus 2 plus cx plus d times, so we are left with x minus 1 squared. So that's it. So let's expand the right hand side and compare, because this is an equation, so we need to compare. So let's expand this. I have, okay, let me just multiply this first, this to that, x cubed minus x squared plus 2x minus 2 plus this bx squared plus 2b. Why this is case, this is x squared minus 2x plus 1. So we still continue. This ax cubed minus ax squared plus 2ax minus 2a plus bx squared plus 2b plus this 6cx cubed cx cubed minus 2cx squared plus cx plus dx squared minus 2dx plus d. So, and we'll group. So let's look at the ones with q. So I have a, and that's a plus c times x cubed. So let's look at squared. I have this, I have this, I have this. So before this, okay, b is there, minus a is there. So let me just cancel out so that it will be easy. We've cancelled this. B, we're on squared, so b is, this one is gone, this is gone. So we are left with this, that's minus 2c, this is gone, plus d, so this is gone. So we are done with we are done with x squared. So let's look at x. So I have 2a, I have plus c, I have minus 2d. So this is done, plus c. So okay, so finally we have the constant, the one just without x. So I have d minus 2a. This is gone, this is gone. Okay, plus 2b. So, oh, okay. So we have 10. This is 10x squared plus 2x. So as you can see, we have x cubed. There is no x cubed in the left hand side. So which implies that a plus c is 0. So we'll assume that the coefficient is 0. That's why there is no x cubed on the left hand side. So that's equation 1. So is there x squared? Yes. We have b minus a minus 2c plus d is equal to 0. Equation 2. Okay, is equal to 10. Yes, this x squared, this x squared. So whatever that is here must sum to 10. So for x, okay, we miss out this. For x, we have 2a plus c minus 2d is equal to 2. Equation 3. And finally we have d minus 2a plus 2b. There is no constant term, so 0. So we have 4 equations. Okay, let's add the 4 equations. So let's add. Let's start with a. So a minus a 0 plus 2a, 2a. That so a, no a, so it's 0. Let's add b. I have 1b here. I have 2b, so we have 3b. Let's add c. I have plus c, 2c minus, so it's gone. No c again. And d. Let's add d. I have d plus 2d, so we are left with no more, it's only b. So 0 plus 10 plus 2 plus, so we have 12. So what we did is we added equation 1 plus equation 2 plus equation 3 plus equation 4. Therefore, we solve b to be 4. So b is 4. Okay, let's check out 2 and 3. Let's add equation 2 and 3. So let's start with a. Minus a plus 2a, we are left with a. B plus b is there c. Okay, minus 2c plus c is minus c. Y d minus, we have minus d. We are left with 10 plus 2 is 12. So we did equation 2 plus equation 3. So let's still add equation. Okay, let's call it equation 5. So this becomes equation 5. So let's add equation 2 and equation 5. Let's add equation 2 and the last equation. I have minus a gone. B plus b, I have 2b have minus c, minus 2c minus c, minus 3c. D is gone, so we are left with 10 plus 12, 22. So what we did is equation 2 plus the last equation, which is okay. We'll continue. We are solving for c. So I have 3c, that's moving minus 3c to the right hand side. We have 8 minus 22, which is minus 14. So solving for c. C is now minus 14 over 3. So we've gotten the value of c. Okay, if you look at the first equation, you see that a and c are related. A plus c is 0, which means that a is minus c. Since a plus c is 0, I have minus 4, so I have as minus 14 over 3. So I have 14 over 3. So finally, we have only one. We have gotten a, b, and c. So it's d. So let's look at the equation that will help us to get the fourth equation. From here, the fourth equation, if we make d the subject of formula, we have 2a minus 2b. Yes, 2a minus 2b. So from the fourth equation, d is equal to 2a minus 2b. And we can factor 2. We have a minus b. So we substitute the values of a and b. A is 14 over 3, while b is, b is 4. B is 4, so we have minus 4. So I have 2 times, as 14 minus 12 is 2. Okay. So we have that d is 4 over 3. So we've gotten all the unknowns. So let's go back and substitute. A is 14 over 3. Therefore, 10x squared plus 10x squared plus 2x over x minus 1 all squared times x squared plus 2 is now equal to a. The value of a is 14 over 3 x minus 1 plus b. Our b is 4, so we'll have 4 over x minus 1 all squared plus c. C is minus 14 over 3x. yd is 4 over 3. That's all over x squared plus 2. So let's make it more, let's write it more professionally. Since I have minus 14, this is 1, we'll bring out minus, let's say 3 is common in both. So if I bring out minus, so I have 14x minus 4 here. Y 3 times x squared plus 2. So this is more concise. So we've decomposed this into the partial fraction 1, 2, 3. So that's the answer.